Question 3, and I'm now dealing with impulse. Impulse always needs a before and after situation. So let's just make a note of these. We've got a particle of 0.75. The before velocity is 4I, and it receives an impulse, and then the angle between the velocity of p before the impulse and the velocity of p after the impulse is then theta. So I then have this sort of situation where this is now at an angle theta, and let's just say that that's going to be v. Now I can break this down into its horizontal and vertical components, because this would be v sine theta and this would be v cos theta. So thinking about this now in terms of vectors, I can say that the vector velocity afterwards, so my v, is going to be v cos theta I plus v sine theta j. Now I know the impulse equation is impulse is change in momentum, so let's make a note of that. So vector I is m lots of v minus u. Now my vector impulse was 6i and 6j, so let's write that down as 6 is equal to 0.75 lots of v cos theta v sine theta, again using column notation for ease, and I only had 4i in my previous, so we end up with this situation. Now continuing from here, if I divide through by 0.75, I've got 8 is equal to v cos theta minus 4 and v sine theta. This now gives me two equations. I know that v sine theta is equal to 8, and I know that v cos theta is equal to 12. Why have I written them this way round? Well, because now if I divide these equations, what I end up with is tan theta equals 2/3, or theta is equal to tan inverse of 2/3, which I'm reliably informed is 33.7 degrees. In the second part of this question, we need to think about the kinetic energy gained by the particle as a result of the impulse. Now, what have we just found out? From this part here, we've got our v sine theta is 8. So here in my picture, I could draw v sine theta in as 8 and v cos theta in as 12. Now that I've got that, I can use Pythagoras to try and work out what the value of v is. So v will be equal to 12 squared plus 8 squared square rooted. I'm actually not going to bother calculating what that is, because I know for the change in kinetic energy, what are we looking at here? Kinetic energy gained by P as a result. So that's going to be KE after, subtract KE before, because we're looking at kinetic energy gained, so the gain is indicating that there's going to be an increase in kinetic energy here. That should be a half m, and then after is going to be v squared, and before is going to be u squared. So a half of 0.75, and now it becomes apparent why I didn't bother going any further with calculating v at that point, because I knew that I needed v squared, and v squared is just going to be 12 squared plus 8 squared. U squared, well, our initial velocity was only 4i, so that becomes 4 squared. And at this point we've got something around a half, 0.75, lots of 208 minus 16, and again reliably informed that this is 72 joules.